you very much. Thank you to the organization for preparing this fantastic event. So I'm going to start talking a little bit about maybe a little bit of controversy here, but I think it's maybe wakes up people. So yeah, we just mentioned the CEO of CartoDB. You will see a little bit more about it, but basically we do data visualizations and we make maps. And we've heard here a lot of big data awesomeness, like, yeah, big data is going to revolutionize the world. It's just like amazing technology, it's all super fast and so on. We have diagrams like this. People talk about infrastructure, talk about the storage, analytics, like very sophisticated software, like very powerful technology. And what it all ends up is something like this. And this is very sad. This is very sad because, from my point of view, power is nothing without control. I mean, like, you can spend millions and millions on infrastructure, on data analysis technology, and all these amazing things that we've been hearing. But if at the end you don't know what is the results, you don't have a way to understand the data that you're actually analyzing, I mean, essentially you're just at the same stage as that you started. So something that I kind of like try to convene in this type of audiences, the idea that don't just think on big data and data analysis, complete the cycle. So I like to say that big data without data visualization is just a fail. It just really doesn't complete it. I mean, like, the reason why you need big data technology and all this infrastructure is because you have to handle massive amounts of data. Then how do you expect it to be able to make sense out of it on an Excel spreadsheet? Probably going to have to think farther than that. So data visualization is a fundamental part of the big data stack, let's say. Now, I'm coming here to talk about mainly data visualization of maps. And probably, I mean, I think like it's fair to say that maps are probably the most popular type of data visualization. A lot of times people don't think about maps as a data visualization, but most maps that you see, things like Google Maps or Apple Maps, all these maps that you see for directions and for driving your car, it's all data-driven. It's no one really going in Photoshop and drawing every single street. It just all comes from data. And that technology for creating those type of maps is really revolutionizing the way that we understand a lot of data. I'm going to give you some examples. So I like to say something that maybe sounds very obvious, but everything happens somewhere. Think about it. All your clients, all transactions, I mean, everything that you do happens somewhere. And therefore, you have information about the location. And we are still not using it that much. Think about it. So you probably collect a lot of IPs. And you know that an IP, you can transform it into some sort of latitude and longitude. Right? So you are really already probably collecting a lot of geospatial data, but you just don't know it. So think about it. You probably are already doing it. And therefore, everything can be analyzed and visualized on maps. And maps are a great way, a great type of data visualization because it helps people to see the picture really straight away. I mean, like, compare it to the Excel spreadsheet that we see, just the raw data. Obviously, it's way better. And I'm going to try to show you some examples and do some demos to show you the power of data visualization on maps. Now, I'm not saying anything new. I think everybody loves maps. I mean, they are one of the most popular content that you see nowadays on the internet. But making good maps is very hard. And I just want to mention, because sometimes the map that is on the background is a bad map. It's an ugly map and is a bad data visualization. But still yet, we see a lot of data visualization like this. People spending tons of resources on data analysis to end up with a map like this. That's bad. And that's the things that we want to work on. Why making maps is hard? There's many different reasons. To me, the most important one is that the tools are not available there. They are not there yet. Most of the big organizations, they have GIS departments that are responsible for making maps. Most people that know how to use Excel, they don't know how to do a simple map. The tools are not for everybody. Tools are for experts, and not everybody can do a map. Now, with the popularization of things like Google Maps APIs, everybody now can do simple maps, and we've seen it. There's so many maps apps on the internet. But very few people can do good maps, especially when it's a lot of data. So making a map with 100 points, if you're a developer, you probably know that using Google Maps API is quite simple. But if you want to visualize 100 million points, then try it. It's really hard. Technology is not there. The other thing that happens a lot and that makes maps very, very hard from from the previous way that we were making maps is that data changes now all the time. Data is not static anymore. We have real-time data, but not only real-time. I mean, you might have data that just changes every month. And the paradigm of creating a map and publishing, like if you were printing it online, doesn't work anymore. So data is changing all the time, and maps as a data visualization should be adapted every time. It's like if you think like if a Google Analytics, you will just cache it all, print it, and then you will use it. Now you expect data visualization to be connected directly with your data, and when the data changes, the maps update. And that's very hard to do. Now this is what we actually work on, and I want to do a demo. I'm going to be very risky here. I'm going to go on the internet and try to do a demo with the Wi-Fi, and I want to show you why data visualization on maps, how it can be very powerful. So this is our software. It's called Car2DB. So it's a spatial database on the cloud that allows you to do maps. Essentially, when you sign up, you end up in this dashboard where you have like your data sets. I'm going to do an example with an existing data set. The first thing I'm going to do is import the data. So I'm just going to select it from Dropbox because I don't want to upload it. Actually, no, I'm going to upload it. So one way that you can just upload is just drag and drop the file. And if it doesn't take that much time, well, okay, now it's uploading the data. This is a simple example where I'm just like pushing a file. There's other ways. I mean, there's like other workflows where you connect your existing databases and your existing big data infrastructures. I will be talking a little bit more about it. Most of you probably don't know the huge amount of formats that are available for geospatial data. Geospatial data is any data that has location information. That could be latitude and longitudes, could be addresses, could be IPs, could be anything, an administrative area. It could be anything that has information about the location. And that's quite common, and it's available in many formats. We actually tried to solve that. It's pretty hard. So after the data is imported, if we go to the map view, what you will see straight away says the data set that you're looking is every place on Earth that a meteorite has been found. So there is a database of geologists that are basically going and doing a survey. Every time a meteorite is found, they register in this database, and they make it public on the web as an open data project. So so you see this map, and you say like, well, it seems like meteorites just fall more or less everywhere. You maybe see some more density in Europe and United States, but it's very hard to see anything else. That's because this is not the right visualization for this type of data. I want to show you how to do a little bit a better one. It's going to be very quick. So first of all, I want to change the base map. I want to change the base map because you don't need the streets when all you're looking is at where meteorites fall. I mean, so that's one thing that you normally see, like people using Google Maps to represent data about whatever other thing. I mean, Google Maps is designed for helping you to drive your car. It's not designed to help you find where your customers are. Think about it. So I just changed the base map. That's the first thing. We're based on some powerful technology based on SQL and CSS for the styling, but we have some simple tools here that helps you to basically just style the data in different ways. Okay, so I just changed to what we call is some sort of heat map. It's not necessarily a heat map, but it's a density map. Okay, so now it's the same data set. It's around 35,000 meteorites that have fallen on Earth, and we can already see something that we didn't see before. I mean, the first thing that you can see is that there seems to be some areas that are just more popular for meteorites to fall. I'm gonna go a little bit farther. Something I didn't do, forgot. So I have a column here which tells me there is the mass. Just imported it. So mass tells me how big was the meteorite that fell down. So I just changed it. I just cast it to a number so I could use it. So I go back to map view. I click here, and instead of doing this type of map, I'm gonna do a bubble map. So a bubble map is a map where we change the size of the point depending on a variable. In this case, the mass, right? So I'm just gonna go. I'm gonna change a little bit the styles. I'm gonna change this to something like different method for partitioning the data, for doing my quantiles. I'm gonna multiply it. If I do this, I change this to something a little bit bigger. Well, something like that. We should start seeing something a little bit better. I mean, this is just a map I've just done in a very few minutes. It hasn't really, I mean, you can really devote much more time by looking, for example, at the CSS, how you do it. You can change the sequels. You can change a lot of different things. But now let me show you some story already on this data. Something that is very curious, or I find very curious, is that in Yemen, there seems to be a lot of meteorites. And why is that? Well, we find out when we map it, we were like, why in Yemen? We were just wondering. And we searched for internet, and it happens that there is so-called meteorite tourism. There is people going to different countries to try to find meteorites. And where will you go? Well, you can go to the Amazonas and try to find it in between the trees, or you can go to a desert where the meteorites, when they fall, they leave a crater. So why do they go to Yemen? Because there's just a very good place to actually find meteorites. And that's why we have so many there. Okay? So that's already one story that you're getting out of your data that you just couldn't get if you wouldn't be visualizing it in this way. Just wanted to show you a little bit of kind of like an example of why data visualization and maps can be very useful. We got a lot of other examples. So you've probably seen, you've seen election maps. So we worked with the Wall Street Journal during the last US elections. The mapping elections is a very interesting experience. First of all, because you have data that is changing every 5 minutes during the election night. Data is just coming and coming, and you have millions of people looking at those maps. And if you have to solve that type of problems, data that changes a lot, data that gets accessed a lot, you just have some really interesting challenges there. You have some other more analytical type of applications. So all these are applications that are built on top of our software, but there's also some other examples that we can look at. But you might want to have like a dashboard, like in this case, the United Nations doing, where they can draw polygons and get information. They can do what we call geoprocessing. It's like, how many Starbucks are in this polygon? This is the most ugly example. But what about how much is the deforestation on this particular area of the world? That type of question, that type of asking like how much or what is the average inside the polygon is what we call a geospatial intersection. And that's part of a geospatial database. That's what the kind of like the things that you can do with this technology. Some of the other maps are more narrative. So they are more about telling the stories. I will go back a little bit about telling stories, but that should be something that you should keep in mind. Data visualization is mostly about telling stories, like in this example with The Hobbit. This is a very simple map that we make on a weekend. Last year, there was the 15-year anniversary of the Rolling Stones. And we just went to Wikipedia, and Wikipedia has every single concert that the Rolling Stones have made. We just downloaded the data and just put it in a map. And suddenly we had actually the managers of the Rolling Stones calling us to actually get the map. So maps are very popular. They're very sticky. People just really get it. So think about it, how you can leverage that power. German press. It's important. Of course, I don't know how much has been talked on the conference, but it's really important the fact that maps and especially content that has to be consumed more and more is being consumed on mobile. So technology, whatever technology you think on data visualization, has to work on tablets. What we see now on our service is that most of the visualization to maps comes from iPhones, comes from tablets, comes from Androids. And the reason for that is that people, want to consume information while they are not working. So they are maybe on the bus, there's something. So think about it. So your technology that you do for mapping has to work on mobile. It's a requirement. There's other thing that I like to say is like, not everything happens somewhere. It also happens at some time. So there is a new technology that we're releasing actually this week for doing what we call geotemporal visualizations. So data that changes not only on the space, but it changes over time. And this is an entire new area for mapping and GIS. We're just basically trying to find out new ways that we can represent data that changes. So doing this type of visualizations here, what you're looking at, at ship routes. During the First World War, there's a story behind it. You can see, maybe you can saw it. Let's see. So here, for example, there's the First World War. There's a lot of movement in Europe, but there is the North Sea naval blockade. So you see there's not much traffic between United States. And then United States enter the war, and suddenly there's so much more traffic in the Atlantic Ocean. So again, finding trends. It's a data visualization we made with the BBVA, a bank in Spain. And they basically during the Mobile World Congress, well, if you've been there, it's a crazy event. There's so many people, there's so much going on. And we wanted to see if we could actually detect the impact of the Mobile World Congress and data. And one way we did it is we're working with the VVA. They gave us data. They're working a lot on on some. I think there's been some presentations, but they're doing some amazing work trying to analyze the data about credit card usage and things like that. So what we wanted was to compare, and this is a very short video, but on the left, what you have is the week before the Mobile World Congress, and on the right, you see the week of the Mobile World Congress. And in purple, you see transactions done by foreigners, and in blue, you see transactions done by Spaniards. What do you see now? It's like, particularly, there's a very interesting, there is a very interesting trend. So you see now, we're coming to the end, so it's 11 p.m., and you see now how much more purple is on the right? People really like to go out during the Mobile World Congress. So another story, I mean, like, again, I mean, what I'm trying to convene is this idea. There's always stories behind your data. Go for them. This is the same Meteorite map that I just made live. But I mean, like, just if you spend another 10 minutes, you can make it look a little bit better. We did that, actually. The map, that map, I just made it after, you know, the meteorite that fell in Russia. It got, like, super popular. We published it, and we got, like, 10 million visits on this map. I mean, like, I think there was more than 160 media republishing it. So think about the power of, you know, like, telling your stories of your company or your organization through data visualization. It's a very compelling way. We work with traffic data, for example, with Nokia. Again, very important. Think on mobile. I mean, most of your content is going to be consumed on mobile. We've been seeing also applications that are more analytical. Things like, you know, where should I live? I mean, how much I can afford. Maps are a great way to, you know, like kind of like explore between the data. You know, like if you don't wanna commute more than 50 minutes per day, and you cannot afford more than £500,000 house, where should I live? I mean, that's the information that maps can tell you straight away in a much better way. So think about it, how you can do it. Another example I wanted to show you is about big data analysis and deforestation. So that was actually my talk. We working with an organization called World Resource Institute, and we're trying to do something that is very innovative. We're trying to track global deforestation almost real time. And might sound like something that might be existing already, but most of the deforestation analysis that you find by scientists and by governments are done on a yearly basis. You know, we get to know when something has deforested in the world 1 year after it happened. That leaves us very small space to actually, you know, like, you know, get action in the field. And that's something that we started working with them. So the way this works is a project we call Global First Watch. It's going to be published in the next 2 months, I guess. It looks something like this. It's a map. You can see already like a deforestation around the world. This is an example in Brazil. The interesting thing here is that we have this kind of like this idea of using a map like a YouTube video. So on the bottom you have like a player. So you can just recreate how deforestation happened. And if you just click play or you just move the slider, you see how the deforestation goes on, right? And it's pretty dramatic in some areas in the world. It's really, I mean, you can just really see it. That's a very power, you know, in terms of, you know, data visualization. Now, the data that it takes and the analysis that it takes to do this type of, the technology it takes to do this type of analysis is, I mean, things that you can imagine. I mean, we had to process the data using Hadoop. Basically, we take every image that comes every day, compare the value of every pixel to the previous day, or, you know, or the previous day that was not cloudy, and, you know, a lot of analysis like that. And basically, we try to find what we call alerts, saying like something is changing here, so it might be that there's deforestation. So this is the kind of like analysis that you also do with satellite imagery. Sometimes, I mean, like you see very clear, you know, like cases where essentially the deforestation is happening in protected areas, places where it shouldn't be happening, and we can get that information and stream it straight away. It's very powerful in that sense. This is a beautiful, well, it's a sad story, but I find it very interesting because it's another example of how visualization kind of like helped you to find out things. And so this is the data in 2011. It's in a part of Malaysia, and that's, you know, there's deforestation in different parts. There's a lot of deforestation going on in Indonesia these days. But what you see here is an area that actually, it's a protected area. And since 2011, when you were zooming in and you were panning on the map, we started seeing this little, you know, like in the center, you see how something is developing. Like this. Suddenly, in a matter of 2 years, we got all this deforestation going on like this. And that's what's very obvious when we were looking at the map. So we started looking a little bit more about what's going on there. And what was going on is that they constructed a dam. So essentially, they put a dam, and of course, then everything gets flooded, and there's a lot of deforestation. And this is a case of, like corruption and, environmental issues and so on. And we could just find it out like that. Then we look on Wikipedia, we found an article about it, and you could just then build the entire story out of it. It's just one more example, like how data visualization is not just something to entertain you. It's something that can really produce the value to get something that you wouldn't get with just analysis. But I also wanted to kind of express, I've been here for today, so I wanted to, I just hearing a lot of technology and a lot of, great ideas. But, well, first of all, I wanted to give my personal opinion. Most people don't really need big data technologies. A lot of the projects that we do, I consider that we use quite a lot of different technologies for big data, but most of the time we don't use them. Most of the time you just really don't need them. And when we work with different organizations, we see that they are thinking about big data, but when they actually should be thinking, it's just start collecting data and analyzing it. Their existing database can already handle it. So sometimes it's not a problem of big data. It's about thinking on the way of, I need to start analyzing data. Think about it, okay? So don't focus on the technology so much. Probably your database can already do it. At least the first analysis that you're going to be doing. Don't start, building a huge Hadoop cluster for analyzing 1,000 records. Excel can do it. It's as sad as that. And the other thing, I hear a lot, saying like, what technology should I use? You're not Facebook. Maybe there's someone from Facebook, great. Or from someone from Twitter and it's rich today, but most of us, we are not Facebook, we are not Twitter, and we don't handle the amounts of data that they handle. You don't need to be sold on the same technologies that are created by companies super specialized on one single thing. Think about it. Is it really the same type of technologies we need to use? Well, just in some cases. But when you really need to use big data, things like I was showing on deforestation, in those cases you really need to use those technologies. You just can't handle like billions of records and things like that in a relational database. Well, for that, what we've been working a lot, and I asked you to actually take a look. How many people use Postgresql in here? So it's quite a few. That's great. So Postgresql is probably the best open source database. Well, it's not probably, it's the best open source database available these days. It's much, much better than MySQL. Believe me, try it, give it a try. It's evolving really, really fast. And since a few years, there is this new concept of what is so-called foreign data wrappers. So it's a way to connect your existing relational databases to other external resources so that you can use, we don't need to have another SQL in Cassandra to try to recreate like it's a relational SQL and an ANSI SQL. Well, you can actually use your normal SQL from PostgreSQL, which is the normal SQL that you're used to, and and then get it streamed down to a system like Hadoop or other type of clusters. So think about it, and that's our approach. For example, we want people to use simple tools, and simple tools is not writing a MapReduce job. Simple tools is using technology that people already know, and then doing the magic behind the scenes. There's foreign data wrappers for a lot of different technologies. There's also crazy things like, there's foreign data wrappers to Twitter and Twitter API. It's very interesting. So the way that, for example, we use it, when we have to handle visualizations with massive amounts of data, like billions of records, what we normally do is that we cannot handle this amount of data, just to be honest. No, we don't handle. Most of the visualizations people make don't need this type of analysis. But when they need it, what we do is we connect our technology to one of the existing technologies like Hadoop. So like, if you're looking at a map of, let's say like 10 billion points, it's unlikely you want to see 10 billion points in a map. First of all, because there's not enough pixels to see them. So what you start doing is you have to start doing aggregations. And those aggregations are very, very, very good done on something like Hadoop and on some of the technologies that you've been hearing these days. So, so what we can do is leverage the power of these big data technologies and then stream them back and then use them for the visualization. And that's how we kind of like doing this type of projects these days. I also want to get a little bit more into the concept of geotemporal visualizations. We're working on it right now quite a lot, so I'm very excited about it. But I also think it's a game changer. I think a lot of people are going to start, finding things on their data that they haven't seen before. So I want to tell you a little bit about our technology. So I didn't mention it, but all our technology is actually open source. We have a business, and it's a software as a service, but all the technology that we leverage is open source. So the implementation that we've done, the technology that we've created for doing this type of geotemporal visualizations is called Torque. And what it does, essentially, is creating something that is not so new. I mean, it's been for a long time, but I think a lot of people have forgotten about it, is the concept of the data cubes. So there's, OLAP cubes and so on. It's been for a long time, and there's a lot of, ideas around it. But, basically what we're trying is to leverage that type of technology for geospatial data. So what we do is we think on the data as a three-dimensional, at least three-dimensional, in some cases even more. Where we basically aggregate by the location, by the X and Y, latitude and longitude, and the time. So when we look at a map, we don't look just as one single snapshot. We think of a map as a movie. And a movie is made out of frames. So the way that you actually aggregate the data and prepare it for displaying on the browser, on your mobile, is just by doing this type of aggregations. And this is where big data really, really helps, because this type of aggregations can be very expensive. This is, for example, an aggregation that you will do on SQL. The fact that we can do it on SQL doesn't mean that we have to run it on a relational database. That can be transformed into other type of languages. But essentially what we're doing is aggregating, is doing a group by X, Y, and time, and making time buckets. So for every pixel, it doesn't matter if there's one record or there's 1 million records. We just have one single record for it, and we know behind this pixel, there is 1 million records at this particular time. The result is this type of aggregation. It's a type of JSON. We have some binary formats. I'm not going to get so much into the technicalities of it. But the interesting thing of it is that the format scales really, really well. So it doesn't matter if you're representing 100 records or you're representing 1 billion records, because it just aggregates. Like I said, there's so many pixels that you have on the screen. There's no point on going more than that. So by using that type of concept, we created this technology for representing this type of data, and it's been very effective for a lot of different projects. I just want to finish with a little bit of a thought. I thought like it could be useful to kind of give some final words about. Just think on the value of your location, of the location on your data. Most people don't really think about it, but you probably have already location on your data. Think about it and try to use it, leverage it. Geospatial data is probably the easiest way to get return out of an analysis. I mean, when you map things like your customers on a map, you learn so much more than doing other very, very complicated analysis. Just think about it. And try to do it in a very fast way. Try to do it try many different experiments like that. Again, complete the whole big data cycle. Don't end up on the technology, on the analysis. I mean, it's not about who has the biggest cluster. It's about who made the most sense out of the data. So complete it. It doesn't have to end up on an Excel. It has to end up in a report. It has to end up in information, something that you can then make action. And finally, the best way to actually convene a message about something that you find is to find the story behind it. How it happened that suddenly you have so many customers in Moscow. Well, maybe there was, the first customer and he was an ambassador and he just started spreading. Try to find those stories and use that to communicate your data. That way you will probably, make much more return out of, people will really like, what you're doing. They will appreciate, and it will not just be like, wow, fantastic big data or nothing. So thank you very much. And if you got any questions, I don't know how much time I've spent, so. We have plenty of time. Okay.
Hi, I'm really interested in how you mentioned you actually did analysis on Hadoop on the satellite images.
Mm-hmm.
How does that work? You make tiles of the image and do small processing on each. Can you explain a bit more? How do you do that?
Right. So yeah, actually, you can probably look at it from here. So if you've worked with maps, you've probably seen most things like Google Maps actually work on this concept of tiles. When you're looking at Google Maps, it's not just one single image. It's made of smaller images that they load progressively. I mean, it's not that you download an image of the entire world. Just download the ones that you're looking at. So, so it's made of smaller images. So analyzing this type of data, just basically you leverage that. So what you can do is what you get is we use different satellites. There is different constellations like Landsat and MODIS that basically produce these big data files. You just cut them in pieces, and then you send them for analysis to different kind of like, to your cluster. I mean, it's a little bit more tricky because you cannot like perfectly just sort by the tile. You have to also give it context because, like then if not, you will have like border effects when you're doing the analysis on the map. But yeah, but essentially you can parallelize that very well. So it's that you don't analyze the entire image at one time, you analyze it in pieces. And you normally start actually analyzing at different zoom levels even. So you start at one resolution and then you just go down to fine grain. And when you do analysis at something like, I think like right now, the ones that I was showing is 500 meters resolution, and we can go now to 250 meters. There's even data sets that we're working at 30 meters resolution. And some of those can be really, really data intensive, going all the way down. And the way that, I mean, like there's many different types of algorithms that you can think about finding deforestation. But think like if you have a time series of data, for each pixel on the image that you have, what you do is you basically look at its properties. What is the color? And if you see that color changing over time, you basically create finally kind of like a curve. And of course, the planet is changing during the year. So some days, the trees change. They are not always green. So what you cannot just look at, like has them been changed. You have to look is like, is the change that has happened different than the change that I was expecting? And by how much? And that's when you start like kind of like, like firing alerts and things like that. I mean, like basically producing another data sets of alerts. There's many different ways of doing this type of thing, but it's very good for parallelization.
And about the specific technology, it's internal libraries, or are you using some standard image processing tools?
I mean, like it's all pretty standard. I mean, like it's all open source, and the actual, like the actual analysis of pixels, you can do it just with the simple map reduce on Hadoop. I mean, all you have to do is, I mean, instead of having like a list of a CSV file, you basically serialize the image, and you have like a pixel and the RGB values, and then it's more or less the same. So there's nothing really specific about it. There is open source libraries like GDAL, even ImageMagick can be sometimes very useful for using for doing some of these things. So there's definitely open source is enough for doing these things. You don't have to go any proprietary here.
Thank you.
Okay. Any more questions?
Hi. Well, I just wanted to know what's been the most data intensive problem that you have to solve with I guess with CartoDB or
yeah. I think like probably, I mean, there's been many. I mean, like each project has its own challenges, but there is one that I really like. There's this project called Encyclopedia of Life. Essentially, what it tries to do is have a page for every species on Earth. And so we're very big fans of biodiversity, species, protected areas, and things like that. So we actually got interested in doing maps because we wanted to do a map of all the species on Earth. And doing a map of all the species on Earth is a very hard thing. It took us probably 5 years to get it done. So, but yeah. So essentially, this is a very interesting topic. So the biggest challenge you have it on data that is multidimensional. Biodiversity, things like this bird. Okay, it's house sparrow. Let me look at the map. We have it here. Somewhere the map should appear. But essentially, what we are representing here is all the data collected about this particular species. So this is what we call primary data. So scientists go to the field and they collect a specimen, a particular bird in a particular place in a particular time. So essentially you have like what species, in what location, and when. And these three components are super fundamental for biodiversity analysis. And when you try to do a map of all this, you suddenly come with a problem. Like, let's say like, well, let's generate the map and then we just pre-process it all and then we can just present it. But we have 1.5 million known species. So we will have to generate 1.5 million maps. We cannot do that. You have to basically do it dynamically. The other thing that you have is like the location. I mean, like you can aggregate, but I mean, like you have latitude and longitude. So essentially, each map can be like gigabytes and gigabytes of data, and we have 1.8 million maps because we have 1.8 million species. So that's actually is a very interesting technology problem. So we couldn't really render just one single map. We had to prepare a data model around it so that this will allow us to dynamically create the map based on the information that was being requested. And that's, I think, this is, to me at least personally, is a very interesting story. There's actually a very, I don't probably have it now, but let me see if I can find the okay, well, I'm not probably going to find it, but there's a very interesting story about in the beginning of the century. Basically, there was some group of people that they were called introductionists. So their goal was that they thought it was a very great idea to take a species from one place on the earth and put it somewhere else. So their idea was like, well, if God has created them in England, they should be also in the United States. So what they did, there was this guy that took all the birds on Shakespeare bibliography. They took a couple of them and shipped them and released them all in Central Park in New York. And that was around 1892. So most of the species died, so they didn't survive. But 20 of them stayed, and they became invasive species. And one of them particularly has been really amazing because it has conquered the entire world since then. And you can see it out of data. And that's the kind of like the visualization. So this is, for example, a very, very interesting analysis we had to do. Oh, here it is. It's a pity. I don't know if I can put the sound. Well, it doesn't matter. But we wanted to make it loud. You know, like we wanted to sound like birds. So what you're seeing here is the map about this particular. Oh, really? Maybe. Okay, let me see if it works. I haven't tried this in years, so I'm not sure if it actually works. No, it doesn't really. Okay, so the idea here is that you could see the sound, and you see now, let me go to United States. So we're talking about here on 18th century, so they were released in 1890, 60 birds released in Central Park, and the first time they were looked at it was in New York. So that's the first record that we see here. And since then, they started, you can see how they started spreading, you know, and how it goes from the West Coast, from the East Coast to the West Coast, until it covers the entire United States. The sound is just to make it disgusting. This is invasive species, it shouldn't be nice. So, so that's why, you know, we wanted to make it like that. And that's a very type of, you know, like a very interesting story here. Now this species is actually found all around the world. You can see it's native only in Europe. It shouldn't be only here, but it is spread all around. It's a huge problem. For example, now there's only one place in the entire world now where they're still fighting it. It's in Australia. The rest of the world is all already invasive. And the funny thing about it, and maybe this is too long, funny thing about it is that actually now it's an endangered species in Europe. It's hilarious in that sense. But it's a huge problem because it takes the nets from other species, and it's a very big problem. So that's probably one of the biggest challenges that we had visualizing. The data changes every 20 minutes, so it's very, very dynamic data. So that.
Can I do a follow-on in the question? So this, suppose that I have this data already in an Excel or in my system. Would it be easy? Would it be easy to do it out of the box with your system, with your SaaS product?
Yeah, I think so. Let me give you another demo. So so I did one about meteorites. We also support things like polygons and so on. This one I think is too big, so I'm going to load it from Dropbox. So basically it can load from the cloud because data normally is very big. So just going to take, here for example is a map of last elections in New York. So it's a typical map that, for example, a journalist will do. We have a lot of clients, things like the Wall Street Journal, Financial Times, the Guardian, the New York Times. I think we have now around 40 different newspapers using our software. And I think the reason for that is that we were talking before. I think in the previous one it was being told. I mean, like journalists don't have, normally a GIS department. They want to tell stories, but they don't know how. And like providing technology that is accessible to anybody. I mean, you're just looking at it. I mean, I just imported the file. I can just directly see it here. Well, see. Again, like this is, for example, a 30 megabytes file. When it uncompresses around, I don't know, 100 megabytes. So you cannot do that with normal technology. So like journalists find this very easy to basically do these maps by themselves. So I'm going to do here what is called a choropleth. A choropleth is when you basically draw the polygons. Each of these is a county, and we're going to draw it depending on how much they voted Democrat or Republican. So in this column AB, for each county, we have, if it's 1, everybody voted Democrat, so it's the percentage. So if it's 0, everybody voted Republican. And you can already see some interesting things. I'm just going to remove the stroke. Let me change the base map. Change to something more dark. And you see, this is a typical pattern in the United States. I'm going to change the palette, because the color ramp. I use a different one. Oh, didn't want to use this one. Oh, I need to use this one. So you create a map like this, and you can see already, like basically rural areas are much more Republican than, like cities. So New York is a highly Democrat place. But, like the rest of the state is quite Republican. So it's as simple as that. They do it like this. I mean, you can do a lot more styling. And finally, you can just click on visualize and say like results of elections. You create a visualization. A visualization is basically you can have multiple, change the color. I can add the description. Results from the elections, live demo, whatever I wrote. Yeah, and then you just click here, publish, and have to make the data public so I can visualize it. And suddenly, you just basically it's like you have a YouTube video. You can then click here, click on embed, and put it on your blog or on your journal, or you can just basically go to the URL. Copy it. Let's say that you also want to have like Twitter and so on. You just publish it, you put it on Twitter, that's it. So it has to be, I mean, that's what we're trying to change. We're trying to make people to make maps in a much easier way, and maps that are scalable. This is the big difference with other products. We don't want to make a software for professionals. We want everybody here in this room to be able to make a map.
Okay, we have time for one last question. No last question. Everybody's hungry. Okay, so let's thank Javier